Hi everyone, welcome back to session two. In this weekly session, I want to give you guys more tools and more hints on the first project. So first things first, let's go to our GitHub repo. So we discussed this a little bit in the first session. This URL is github.com echal-in paste-u-cs676. So this is the course URL for the GitHub. And then you want to check your branch. Default should be main branch, but we are 2025 fall. So click on that. And then the place that we're talking about for project one is in the documents. But you can scroll down to the table of contents and click on capstone project, and that's really the same place. I'll take you to this link here, 12 capstone. Clicking on that will giving you this kind of markdown file. So right now we are in the docs folder. The name of the markdown file is 12 underscore capstone. So if you see this directory and it's under 2025 fall branch, then that means you're at the right place. So project one is listed here. And in this video, I want to give you guys a bit more hints on what exactly is going on for project one. The dates of the deliverable are listed out here in the links. Like for example, deliverable one, it's September 19th. Deliverable two is September 26th, and so on and so forth. They're all listed out. And like I said before, I don't really tell students to submit anything tomorrow, right? That's not how you run the class. September 19th, it's 10 days ahead. So hopefully it should give you plenty of time. But the way I run these projects are iterative, right? So what I mean by that is you will be doing project one throughout pretty much entire September and a little bit in the beginning of October. So really, you'll be doing the same project for pretty much, I would say, 4 week, maybe a little bit more than 4 weeks, right? And then hopefully that should give you enough time to finish the project. And deliverable one, two, three are iterable, right? So in the next few minutes, I'm going to explain what do I mean by that. So click on this first link. It will take you to this section of the Markdown file. It's called credibility score for articles, sources, or references. So here's the problem statement. Let's start with the situation, right? You have a chatbot, right? You have a chatbot. A user can enter something, right? Spine surgery, recovery, or whatever, right? Some sort of prompt, right? Some sort of prompt. And then the chatbot then go along, search internet, whatever, right? Search internet, search database, whatever. So it does its search, right? And then it responds something back. Say, oh yeah, here's some key points about spine surgery recovery, blah, blah, blah. And then here are a couple of links. Now here's the problem. How do users trust these links one by one, right? How do you help user achieve that goal, right? Which one should you click on? Which one should you not clicking on, right? And how do you understand it, right? So to mimic this situation, I can open a new tab and go to perplexity.ai, and then I can type in the same thing, right? What exactly is a search query? It's a spine surgery recovery. So spine surgery recovery. So let's type in spine surgery recovery. So Perplexity, the good thing about Perplexity is it always runs the internet search and it draws the resources, right? References, things like that, whatever that means, right? It could be a video, it could be an article, it could be a blog, right? And then you get a couple of bullet points, right? Typical recovery timeline within 2 to 6 weeks for light activity, for full recovery takes 6 to 10 weeks, and that's according to this link, right? Whatever this link is. So you can keep going, right? You can keep going and read the whole thing, right? So it is definitely more efficient than if you take the whole thing, take the same query and then run it through Google search. I can do the same thing for you guys. You can run through Google search, and then you can then read this whole thing one by one, right? WebMD, it's a bunch of links, right? It's a bunch of links, and then you have to read it yourself. You can watch videos, you have to watch it yourself, or you go to AI tools like Perplexity AI, it will probably take the summary and then just write it out for you. So you just read a summary of each links, right? So both ways work, right? Both ways work. You're gonna get some information one way or the other, no problem there. But the problem statement is how do you trust each link, right? How do you trust each link, right? How am I supposed to learn from bullet point number one? Do I take for granted? Do I say, hey, this is a questionable? Do I say, hey, this is not trustworthy? This is a trustworthy? What am I supposed to do with it, right? Same goes with Google link. You read the information here. What am I supposed to do with this, right? Am I supposed to trust this? Am I supposed to not trust this, right? It's a problem. It's a problem because it takes additional brain power, right? And it causes additional challenge for user to understand and potentially take advantage of these information. So you presented the information, whether it's Google search or Perplexity, you presented the information, right? How are users supposed to take advantage of the information? What is the action here, right? What is the action here? To go to that, to achieve that goal, the question now becomes the rating, right? What is the rating of each one? You have to start from somewhere, right? If you have a chatbot that is not only able to give you a list of sources, but is also able to give you the ratings, then maybe we're talking, right? Maybe you can say, hey, the first one is 5 star. Maybe that's more trustworthy. The second one is 4 star. Maybe it's just information only is, not trustworthy and depending on your situation, right? So if something like that can be done, then that put a lot of value and leads to actionable item for each one of these options, right? And then the benefit of these stars is once you come up with a system, it can then be customized and tailored by every single individual, right? So that's what I want you guys to think about, right, for this first project. So that is the project number one. That is the project number one, right? However you want to do it, that's on you, right? And then obviously I'm going to give you guys a few more hints. I'm not gonna just leave you hanging, right? This is the problem statement, right? This is a problem statement. So once we understand the problem statement, let's take a look at the deliverable, right? So let's go down here. Let's take a look at the deliverable. The deliverable is broken apart for 3 deliverables, right? Now, this is just a recommendation. You don't have to follow these 3 steps one by one, right? You could do all 3 in one deliverable, and then deliverable 2 and 3, you can then iterate on that, right? Perfectly fine. That's no problem at all. The deliverable 1 to 3 written here, right? Written on this markdown file, is just recommended steps that you need to think about if you're gonna actually physically do this project and think about these in details, right? Because devil are in the detail, and then if you want to think about the details, this is how you do it, right? So first thing is you have some sort of Python script. You have to get your hands dirty. You have to think about the data. You have to think about what the problem is and how to present that problem in Python, right? So that's number one. Whatever that idea is programmatically, it could be fake data, it could be toy data, no problem there, right? I'm not saying you guys have to use real data, right? You can hack it using ChatGPT. I'm going to show you guys how, right? But you need to at least think about the problem using program, right? So that's number one, right? You need to do that. So if that doesn't exist, then you're not going to have a chatbot, right? You need to have some sort of programmatic approach to at least write the problem out, right? So that's number one. So that's why deliverable one is just whatever the idea is in terms of a program. Now, that being said, some of you already know chatbot, some of you already built chatbot before, then you can move on to the deliverable 2 and 3, right? So once you have some sort of code that you know what's going on, the next thing is obviously to write it out, right? Write the code, run the code, whatever the results coming out of the code, that will be the technical report, right? So report just means whatever results that you have. Technical report just means it's coding, right? So it's plain and simple. It can be a markdown file. It could even be like a bunch of paragraph, hashtag comments in your Python script, right? Whatever format, it doesn't matter. As long as you have some sort of um, uh, paragraph, some sort of comments to display, right? To display what exactly it is that you're running from step one, right? So then that will be what I consider step two, right? So once you have step one and step two, then obviously you can move on to build the thing, right? So you have your idea in program, you run it, you have results, right? So then the last then step is to build the app, right? Also, that's the idea here. And then I'm going to show you guys a little bit what I mean by that, right? So the hint, right? The hint of how to solve the problem is listed here under the approach, right? So we talked about the problem statement. Problem statement is it's difficult to utilize and take advantage of the information, whatever chatbot that you're using, whatever Google search you're using, right? It's difficult and challenge to take advantage of the information. The problem statement is in what approach, to what extent can we come up with a solution such that we can rate or grade these articles, resources, citations, references, so that user can then take advantage of the information one by one, right? So that's why these stars exist here, right? So that's a problem statement, right? How do we do this, right? How do we do the star thing? So that's a problem statement. Now let me take a little bit of a minute to talk about approaches. First one is very simple, machine learning, right? We're all data scientists here. We're all trying to learn something. Let's use data science, right? So that's the first approach, right? That's almost like a no-brainer. So machine learning. Machine learning means you're a data scientist, right? You're training a model. So training a model means you need to have data, right? So that's like a step number one, right? So very simple, right? This is how I would go about it. So you go to Wing 360 search. You can use my chatbot if you want to. You can use your own chatbot. You can use ChatGPT. But this is just going to be how I do it, right? First things first is I'm going to talk to my chatbot and say, um, give me some Python code to simulate data in pandas that can be exported into a CSV file. You can just bake up some sentences in column one and column two. I want you to provide a numerical scoring system. I'm gonna say for the time sake, just out of 100 points. And I want you to give me this Python code, right? So hopefully this will give me some Python code to do just that, right? And then the same time I'm waiting for this, I'm gonna open up a Colab. Very simple. I'm just gonna Google search it. First thing come out. That's really it, right? And then I can say Control Alt A and then Control Shift D to delete this. Then we're good, right? This give me a very quick Python environment. And then let's quickly take advantage of this Colab environment to then run this code a little bit to see what's going on, right? So we have a couple of sentences, we have descriptions, and then maybe we have scores, right? Description's fine. We don't really need both. We just need one, right? So let's grab that. And then we're gonna put it here. We're gonna run this code. We're gonna see what's going on. Hopefully, once it's finished, it will present me a data frame with three columns, sentence, description, and score. And then let me go to directory. Let's see if save it, right? Because here it says to CSV, to CSV sample data, that is there. I can open that. And then boom, it quickly give me this data set, right? So, and you guys get the idea, right? I'm quickly simulating a small language data set, and then just, out of the box using AI, right? Okay, so now we have the CSV, we have the score. Now let's build a model, right? So let's analyze the data a little bit, right? This is a score is a continuous variable because it's out of 100 points. You can of course break it down, right? I don't want to break it down. I just want to think about this as a simple linear regression model, right? Because that's what we're learning first. What we're learning first is a regression model. So I'm gonna say something like this. Okay, great. Based on the data you created above, I want a simple linear regression model that I can train using sentences as features and the score, which is this guy here, score as target variable. The score can be considered continuous. So let's use a regression model. You'll need to figure out how to process sentence, which is string, into features for me. Give me this Python code. So what I just did was I laid out the problem statement for the chatbot to think about for me, right? Behind the scene, it's an AI model, right? Here, I'm using Claude Sonnet 4, right? It's one of the latest AI model from Anthropic. And what's happening here is I want to build a linear regression model. Score is very simple to understand. It's a score, so you produce a score. The features are processed from sentences. So what that means is I need a function to take one of these sentences and turn that into a vector, right? So that's what's happening here. And then you can see that that's pretty much exactly what we're trying to achieve. So what we're going to do is we are going to grab this and then we're going to use TF-IDF, right? So let me grab the code and then let me copy the code out and then let me put it in here to run it. And then we're going to see what's going on. So let me put it here and then we're going to physically run it just to see what's going on, if there's error or not, right? Um, and then hopefully we're going to get some sort of features out of it. Maybe you disagree, that's okay, right? But at least here's a start. So here we go. We run a quick linear regression model, and then we got some features. Before we start analyzing the results, we can take a look at the code first, right? What's going on, right? Let's take a look at first. So we import a couple of packages. Mostly it's scikit-learn, right? That's what sklearn means. We have a vector of sentences, great. You can ignore this for the time being because we are understanding the techniques for now. We're not trying to pay too much attention to the data, right? This data is mocked. So in reality, it's going to be data set like these, right? Um, so that's the data set. Now the first thing to do is to turn into vector. So the key function here is to use TF-IDF, right? Now this is there's a little bit of a math going on here, right? But let's say you don't understand what's going on. The easiest thing to do is you put your cursor here and pop out a window, and obviously you can read about it, right? So that's the easiest thing to do, and then you can Google search this. I can take this, and then I can go here. I can Google search it and then you can read about it, right? So TF-IDF means term frequency, inverse document frequency, whatever that means, right? Of course, you can go into API docs. This is the API docs for scikit-learn, and you can read about this, understand the function, understand the API, and then try to understand what's going on, right? But assuming this is not clear, what I would do is I would take this function and just go back to your chatbot because it has a previous history and literally just put it here, right? So I saw that you used this function. Um, I'm not familiar with this term. Can you explain to me how this function convert a sentence? Let's make sure this is a sentence into a vector. This way, you just let a chatbot tell you what to do, right? I mean, there's a little bit of explanation here, but let's say you don't understand that. You just ask, right? You just ask. It should be able to explain a bit more than what's written here. And then it's also able to, I'm hoping that maybe a little bit math, but let's see. We're not sure about that, right? Maybe example, something like that. So let's see. I'll explain this vectorization in a simple way with an example. Let's say you have three sentences, and after you do this, you print out the features. It will give you something that's like this, right? These are the words. More specifically, these are the unique words. The unique words are made up by the data set. Okay, so that's helpful. And then what that means is it's then calculating the frequency, and then it's able to give you this matrix. And then the number of rows of the matrix is exactly same as number of rows in the vector in the data set, right? So if your sentence data has array of 3 sentences, then this matrix has 3 rows. And if you have altogether unique words to be N, cat, dog, likes, obviously alphabetically ordered, right? Then the number of columns are exactly that, right? So for example, if you have the cat likes milk, which is your first sentence, then the word there come from here, cat come from here, likes come from here, milk come from here. And altogether, this gives you a vector representation of the first sample. Okay, so 0, 0.43, 0, 0.43, so on and so forth. Um, Here is the exact step-by-step procedure, right? In case you have no idea what this matrix means, right? First, it creates a vocabulary. Vocabulary just means you put all the words together and you check the unique words. So it gives you this array. It's based out of the data set, right? And cat, dog, likes. That's the first step. Then it calculates the two components, the term frequency, right? What does that mean? That means how many times a word appears in a sentence. Okay? Then you just, very simple, just count the times. That's it. If a cat appears twice in a sentence, the term frequency would be 2, right? So very, very straightforward, right? If this word appear twice, it will be 2, right? Very straightforward. That's step 2, right? Okay. And what is the inverse document frequency? Okay. So measures how unique or rare a word is across all sentences. Okay. So the IDF, the inverse document frequency, means the logarithm of total number of sentences over the number of sentences containing the word, right? It's just a little math here to tell you how to create that additional feature. An additional feature is this thing, right? And then the common words like the will obviously get the lower IDF score. Rare words get higher score. So that's why this is inverse, right? Okay, so now that we know step 1, step 2, the last step is just to put them together, right? So the final score is the product of these two things. Okay. So words that appear frequently in a specific sentence, right? That's a high term frequency, but are rare across all sentences. High IDF get higher scores. Okay. So that's it, right? That's the steps. So once you understood that, then you should be able to understand that's how it takes this sentence and then turn that sentence into a bunch of numbers. Okay, it's going precisely through these bullet points. Great. So if you don't understand that, there's a small example here for the first sample. The cat likes milk, and then you can check out the math here yourself, see if that verifies it. But for sake of time, we can skip that in the video. But that's basically the idea, and that does the most heavy lifting, right? That does the most heavy lifting because this one function process the entire data set into a matrix of numbers. And that matrix of numbers is going to be what you use as the features of the regression model. Okay, so precisely that's what we're doing here, right? Whatever this thing is coming from the vector, and then you convert it, that becomes the x, right? Once that becomes the x, then you can do your thing, right? Cut it into training and testing, fit the model, and then make a prediction, right? And once you make a prediction, you can check whatever stats you want, right? R score, mean square error, right? All those fun stuff. And then the results are then pointed out here. Cool. Okay, so that's the hint for the first approach. So what we just talked about is the first approach, machine learning based approach. Machine learning, once again, you're a data scientist, you're doing machine learning, this data set. If you don't have a data set, hack it, right? So that you can at least get something started, right? If someone come here and say, well, this data set is wrong, that's fine, right? That's fine. They can give you the right data and you can start a model and it's going to be the same code, right? So you are not wasting time by going through the strategy, right? The data can always be changed and that's no problem at all. I'm not worried about that. in this class, I want you to know the technique. And the technique is how you reason with the code that is a good fit for the data set, right? I'll repeat that again. The technique is how you adapt and repeat and rinse and reuse the code that is good fit, that is appropriate for the data set given to you, right? Data set will always be given to you, right? Your job is not to write out a survey to collect the data, right? Once a chatbot is in the production, this data will be captured, right? So you don't need to collect data, right? Data will be provided for you, right? So don't stress out if you don't have the data, just use AI to create it for you. That's not a problem at all. It doesn't hurt. It doesn't hurt to go through that experiment. Okay. So that's it. That's the first one. Now, second one, what do we mean by that? Second one is rule-based, right? Rule-based. Rule-based is very simple, right? You just make a LLM API call. That's literally it, right? That's literally it. So what do I mean by that? Here's what I mean by that. So uh, let's just test it out with this, and then let's see how what's going on. So I'm gonna grab this first sentence, and then take a look at what the score is. So what is this data frame? The data frame is going to be DF, right? So let's take a look at DF. And then it's the cat jump over the fence and score 60, right? So let me give an example. So I have an example of how I grade a sentence. Sentence, cat jump over the fence, score is 60. Now I want you to grade the next sentence, right? And the next sentence is whatever this is. Students study hard for their exams. Students study hard for their exams. What will be the score? And then you just write this, and then you see what's going on, right? So what's happening is what we're doing here is called one-shot prompting. So what does that mean? One-shot prompting is the type of prompt that provide that provide a instruction such that it contains an example of exactly what you want, right? In this case, it's a little bit random, right? Because the cat jumped over the fence. What do you mean? What do you mean that's a 60, right? It doesn't make a whole lot of sense. That's fine. In reality, you're gonna be putting in sentences that's making more sense, right? That's making more sense. And this type of prompting that provide an example, right here, I said an example, right? It provides an example. It's called one-shot prompting. So whatever the large language model is doing, next step in generating that next prompt is going to be based on what you are talking about in the example. So that example, for the sake of this exercise, inherently becomes the rule, right? So that's why this is a rule-based approach, right? So let me repeat that again. One-shot prompting means that you're providing an example. That example inherently becomes a rule for the large language model, right? That's it. That's what we're talking about, right? And then you can see, okay, it's gonna say, oh yeah, the cat jump over the fence, right? Whatever, like 60, right? Whatever the reasoning is, right? It doesn't matter. Like, LLM can figure that out. And then is then reading the next sentence that you ask, right? Okay, so what's going on here? Sentence complexity, word count, depth, whatever. Okay, given that cat sentence received 60, and this sentence appear to be blah blah blah, I would estimate the score to be around 75 to 80, right? Does that make sense? So, this gives you a small inference based on whatever the example that you give, right? So that's what I consider rule based. Okay. The third one is obviously hybrid, right? You can say, hey, machine learning probably worth 60%, rule based probably worth 40%. Then hybrid is a weighted average, right? Which is a weighted average. So that's 1 to 3, right? That's 1 to 3. And of course, whatever you come up with, the innovative solution, just whatever you come up with, right? I'm always opening my eyes to new solutions. If any student is able to come up with new solutions, please go for it, right? Please go for it. Use LLM, use prompt, use all sorts of resources at your hand, right, to come up with whatever you want. I'm always open to that, right? So those are the hints for the approach. And hopefully this give you a bit more information, a couple of ideas to go about handling this project, right? And then last thing I will say is, just have some fun with it, right? Have some fun with it. There's no right or wrong answer. The most dangerous thing is try to guess what's the right answer, right? There's no right or wrong answer. You need to come up with your own solution, and then you need to iterate on that. So everybody will be providing a different solution. Everybody will be providing their own solution, right? End of the day, you just need to make sense, right? That's all I'm asking. End of the day, you just need to make sense. So hopefully this gives a good amount of hints for how to handle this project. And then if you want even more hint or even new approaches, please feel free to use a large language model, right? Any AI model doesn't have to be mine, but any AI model, right? ChatGPT, Anthropic, any AI model. You can even brainstorm. You say, I want to brainstorm with you. I have a sentence or a string that I want to grade um, or score. Sometimes the sentence contains web searched results, results, maybe an article, a reference, a paper. What are some ways that I can use to grade this uh, response? Please give me a couple of ideas. You can even say without coding. I typically will go about this first because I don't want to constrain myself too much in the beginning. I want to just start with ideas to see, what are some of the light bulb moments, right? What are some of the aha moments that can get a snowball rolling, right? So typically I will say non-coding. And I will just read about these existing tools, right? Here are several approaches to grade or score a sentence, text response, so on and so forth, for web search content, right? Content-based scoring, right? Relevance, key terms, right? Depth of information, accuracy of information, right? Source quality assessment, academic versus non-academic, public date, right? Website authority, right? So on and so forth. Structural elements, right? Grammar, syntax, right? You get the idea. Readability, right? Information, right? So on and so forth. You get the idea, right? Let's say you like one of them, right? I don't know which one you like. You could do all of them, right? But let me just do one example. Let's say you like one of them. Let's say you like this one, right? This is a medical term, right? This example is a medical term. So hopefully, we need to be a little bit more academic about it, right? Otherwise, if something happens, then something is going to be very dangerous, very risky, right? So let's say you like this way, right? You like number two, right? I like the second option. Can you provide some Python code for me to help me understand this process? Let's say I have a sentence, a string in Python, and I want the Python function to take the string as input argument and produce a score. Can you help me with this using the second approach? Okay. So that could be a prompt, right? And then once you just enter that into the LLM, it's gonna write some code for you that you can iterate on, right? That's why we have multiple deliverables. That's how I want you guys to go about it to develop your own strategy, right? That's also why I'm building chatbot for you, just in case some of you guys don't have ChatGPT subscription or wanna. That's what this chatbot is doing here. Just hopefully it's helpful for you. But please, feel free to, use your own chatbot, whatever. Um, okay, I'm hitting an error, but that's okay. I'm gonna copy this, and then I'm going to grab second approach, and then let's see if it's still giving me error. So what I'm gonna do is grab this. Um, and then I'm gonna say, here's the second option. I'm gonna copy this again. I'm gonna run it. If it hits an error, then I'm gonna refresh it. So It might be something to do with the internet. It might be something to do with my API call. But that's okay, right? All chatbots might have some sort of a 504 error. We're gonna dive into that a little bit later, but let's see how well that works. Okay, there we go. So you run a second time, it worked. Great. Um, Great, awesome. So here's a Python code example that evaluates a score, excuse me, a source based on those criteria. This is a simplified version, looks like pattern or whatever, right? Okay, so assess source quality, right? You have a text and then publication date, we don't know, but that's okay, right? You can fill that in later. And then it returns a score out of 100, right? So great, that's exactly what we're talking about, right? So you have number one, academic versus non-academic. Number two, website authority, right? Number three, publication date, right? Whatever. Number four, author credentials. Number five, citations, right? If your citations look like this, right? Usually, if you are a professor, you have a PhD, you're a researcher, chances are you publish paper, right? And if you publish paper, chances are you follow some sort of a schema for citation pattern, right? Maybe you see the index, maybe you see DOI, maybe you see URL. If you have all of those things, then obviously, your score is higher, right? Because that's the pattern that we look for. Great. And then once you have a score, you can then use a little bit of a helper function to return a couple of comments, right? Okay, excellent, good, fair, poor, whatever, right? You get the idea. Okay, so let's test that out, right? So let's grab this function, go to our Python environment, copy paste here, just run the whole thing, right? Boom, there you go, right? So that gives you something even more powerful, right? So that's what I consider innovative approach, right? Because it's not machine learning, right? It's not machine learning. It's also not rule based. It's by particular pattern, right? It's by particular pattern that is a good fit for a particular approach, right? You guys get my idea, right? Because this is not something random, right? This is tailored to a particular assessment, right? Not all the assessment. We're not doing all the assessment in this example, right? Because what did we say here, right? We said that we saw that there are like 10 approaches, right? 10 approaches, right? We're not doing all 10, right? We are doing one of them. And the fact that we're doing one of them, precisely here, number two, is because we are running under the premise that this is a magical term, right? So that goes back to the most important thing here is your score rating needs to be dependent by what the type of use case is. And then guess what? The type of use case depending on who the end user is, right? If the end user is a patient, obviously you want to put more weight on the second approach. If the end user is a PhD student, you want to put more weight on the second approach, right? But that's because you already made the assumption what the end users are, right? And in this case, I don't really want to limit you guys what the end users are, right? You tell me what the end users are, and you give me a system of scores. I don't care what assumption you're making as long as they make sense, right? As long as they make sense. So you guys get the idea, right? You can keep going, and then trying to enhance this function however you want, and then just keep iterating on this project until it gets to a point that it's almost near perfect, right? So this way you can enter a sentence, whatever the sentence is, and then it give you a score, right? So if you can do that, then that's going to be great, right? Awesome. So hopefully this video give you a good amount of information of how to do project one. Obviously, I'm always an email away. If you have questions, feel free to email, and then we can address those questions there. Unfortunately, this is a online async class, so we don't really get a FaceTime. But yeah, I'm always an email away. Please feel free to reach out, and then I'll always figure out a way to help you guys. So thank you for watching, and then hopefully this give you guys enough material for project one, at least to help you guys to think about this problem. And then watch out for the deliverable date. So first deliverable date is September 19th. that give you roughly 10 days. So hopefully 10 days, you should have some sort of Python script um, to at least start thinking about this problem. So thank you for watching, and then I'll see you guys in the next video.